Hello students, I am Annada Shankar Mishra, Assistant Professor in Mechanical Department in Silver University. In today's lecture, we will discuss on milling machine. Here are the some objectives. Introduction of milling machine. So we will know what is milling. Also, we will discuss on principle of milling machine and types of milling machine. There are various of types. Also, we will discuss on operations. At first, we will know what is milling. Milling is a metal cutting operation in which the excess material from the workpiece is removed by rotating multi-point cutting tool called milling cutter. So by using milling process, we can remove excessive material or unwanted material from the working surface. Also, we can make a slot on the workpiece. A milling machine is a machine tool that removes metal as the workpiece is fed against a rotating multi-point cutter. So here we are removing material and the workpiece is feeding against the multi-point cutter, and the milling cutter rotates at high speed and it removes metal at a very fast rate with the help of multiple cutting edges. So in this machine we are using multi-point cutting tool, and one or more number of cutters can be mounted simultaneously on the milling machine, and this is the reason that a milling machine finds wide applications in production work. Use of machine flat surface controlled external and internal threads. So by using this process we can easily remove materials from the working surface, and it is a very fast process. So this is widely used in various industries and we can control it very easily. Also, using this process we can make a threads in internal and external surface of a object. As the workpiece moves against the cutting edge of milling cutter, metal is removed in form of chip. So, also we will discuss various formations of chip because the workpiece is feeding against the cutting tool and machine surface is formed in one or more passes of the work. The work to be machined is held in a vice or rotary table, a three-jaw chuck, and index head in a special fixtures or bolted to machine table. Here, various of motions we will observe like rotary motions, and also we are using three-jaw chuck because by using this chuck we can hold circular, hexagonal or various shape of job, and in many applications due to its higher production rate and accuracy, milling machines has even replaced shaper and slaughter. So milling machines is widely used, so we can replace it as the formations of shaper and slaughter. In the next, by using this process we can machining over surface. Also we can make a slot. Milling methods, two basic methods of milling. One is up milling and second is down milling. Up milling or conventional milling. Milling is removed by cutter rotating against the directions of travel of workpiece and needs stronger holding of the job. Chip thickness is minimum at the start of cut and maximum at the end of cut. Disadvantage: tendency to lift work from the surface and poor surface finish. Here is the conventional milling or arc milling. This is the rotor and this is the cutting edge, and the feeding directions is left to right. In the starting of the cutting, the chip thickness is minimum, and at the end of cutting, chip thickness is maximum. Next is down milling or climb milling. Metal is removed by cutter rotating in the same directions of travel of workpiece. Teeth cut downward instead of upwards. Chip thickness is maximum at the start of cut and minimum at the end of cut. In up milling, chip thickness is minimum at the start of cut and maximum at the end of cut. Less friction involved, better surface finish, and less power consumption. Here are the advantages. Clean milling, it is rotating clockwise. Also, feeding of the workpiece is right hand to left hand side. So both directions is same directions. And here the chip thickness is maximum at the start of cutting and minimum at the end of cutting. Principle of milling is milling cutter, and this is the workpiece, and here the cutting tool is rotating clockwise direction and workpiece is feeding from left to right hand side. So both directions is opposite. So it is up milling or conventional milling. And here the cutting tool rotating clockwise. Also the workpiece is feeding from right hand side to left hand side. Both directions is same. So it is down milling or clean milling. Types of milling machine. The milling machines may be classified in several forms, but the choice of any particular machine is determined primarily by the size of workpiece. According to general design, the distinctive type of milling machines are column and knee type milling machine, planar milling machine, fixed bed milling machine, and special type milling machine. Here we will discuss principal parts: base, column, knee, saddle, table, and spindle. Next is column and knee type. It is most commonly used milling machine used for general shop, and the table is mounted on the knee, which is turned and mounted on the vertical side of the main column. The knee is vertically adjusted on the column so that table be moved up and down to accommodate work of various heights. So it is a very commonly used type, and the table is mounted on the knee. So this is the base on which all the tools are mounted, and this is the column where the knee can move upward and downward direction, and this is the table and workpiece which is mounted, and we can hold the workpiece by using bench vise, which is a tool, and this is the spindle where the cutting tool is or multi-point cutter is attached. The knee is vertically adjustable and the table can be moved, and also we can arrange the tool horizontally using saddle. Classifications of column and knee type milling machines, which is hand milling, horizontal milling, universal milling, and vertical milling. In horizontal milling machine, the milling machine has a spindle that is parallel to the shop floor and an overarm that extends over the workpiece. The overarm supported the arrow bore, which holds the milling cutter. On the horizontal milling, the arrow bore is the component that rotates the milling cutter. This is the horizontal milling machine diagram, and this is the base, and it is the main part in horizontal milling machine on which all the parts are mounted, and it is generally made from cast iron. And this is the column, and it is a hollow section, and all the driving mechanism is here, and the belt driving or gear mechanism is here, and this is the overarm. Overarm generally used to give the angular movement. This is the arrow board on which the cutting tool is attached, and this is the knee, and this is the guideway. Guideway generally used to give the upward direction and downward direction to the knee, and this is the screw jack. It is generally operated by manually, or we can also use hydraulic based mechanism, and this is the saddle. knee can move upward and downward direction, and saddle can move right hand side and left hand side direction. And this is the bench vise. It is generally used to hold the workpiece. So these are the main component in horizontal milling machine. So it is the actual diagram. So this is the arrow bore, and here is the cutting tool, and this is the saddle and spindle, which is in horizontal direction. That's the reason it is called horizontal milling machine. And this is the column, all the mechanism is into it. And next, the arrow bore on which the cutting tool is attached, and this is the shank which is attached with the column, and this is the arrow bore nut. Next is vertical milling machine. So spindle is vertical or perpendicular to the work table, and it has all the movements of the table for proper setting and fitting the work. Spindle head may be swiveled at an angle and permit the milling cutter mounted on the spindle to work on an angular surface. So here the overhead is used to give an angular moment. In some machines, spindle can also be adjusted up or down relative to the work and adapted for mechanism, groove, slot, and flat surface. This is the main components of vertical milling machine. This is the base, and next this is the column, and same the horizontal milling machine. All the driving mechanism is here, and this is the overhead. Overhead generally used to give an angular movement, and the spindle is in vertical direction. That's the reason it is called vertical milling machine. And this is the saddle, and this is the knee. Knee can move upon it downward direction, and saddle can move right hand and left hand side direction. This is same. This is the bench vise, which is used to hold the workpiece. And in universal milling machine, it is generally used to perform the work of same as vertical and horizontal milling machine. So difference from plain horizontal machines is additions of table swiveled. Housing permits table to be swiveled 45 degree in either direction in a horizontal plane, used for milling of helical grooves into steel and milling cutters and gears. So it can perform vertical and horizontal milling operations. And same, this is the overhead or overarm. It is used to give an angular movements. And here is the tools, which is in horizontal direction, also is in vertical direction. So this is the combinations of vertical and horizontal milling machine. And this is the saddle. Same, it's generally used to keep the movement of right and left hand side direction. And this is the knee, which can move upward and downward direction. And same, this is the base, which is generally made from cast iron. So universal milling machine can perform vertical and horizontal operations both. Fixed bed type milling machine, comparatively large, heavy and rigid, and differ from column and knee type milling machine. So it is different from knee and column type milling machine, and table is directly mounted on fixed bed. No provision is provided for cross or vertical adjustment of the table. The cutter mounted on the spindle head may be moved vertical or column, and the spindle may be adjusted horizontal to providing cross adjustment. And mainly there are three types: simplex, duplex, and triplex. Fixed bed milling machine. Here is the spindle carrier and cross rail. This is all the spindle carrier, and this is the workpiece, and table where work is performed, and this is the bed, working bed. Planar milling machine looks like double column planar machine. Milling heads mounted in various planes and vertical heads on the cross rail and horizontal heads at the side. This arrangement enables to machine a workpiece on several slides simultaneously, used for producing long straight surface on the large and heavy machine parts. So it is generally used for straight surface and large surface area, and it is generally used for heavy work. Special type milling machine designed for individual milling operations, used for only one particular types of job, and completely automated employed when the hundreds of thousands of similar pies are to be machined. So by using this process, we can produce mass of production. And tracer milling, also called duplicators, and designed to produce an irregular parts geometry that can be created on a template in two-dimension tracer and in three-dimension duplicator. So in two dimensions, 2D from it is called tracer, and for three dimensional it is called duplicator. CNC milling machine, computer numerical control milling machines, cutter path controlled by the numerical data and suited to profile, pocket and surface control. So this is a automated based, and here we can use numerical data. Milling operations, plane or slab milling. So these are the operations in face milling, end milling, side milling, slot milling, and angular milling, forming milling, and straighten milling. These are the main operations. Also, we will discuss on saw milling, gear cutting, keyway milling, and string milling, profile milling, thread milling. It is important, and helical milling and cam milling. In slab milling or plane milling, process to be get flat surface on the workpiece in which the cutter axis and workpiece axis are parallel. The primary motions is the rotations of the cutter, and the feed is imparted to the workpiece. So this is the workpiece and this is the flat surface, cutter, plane milling cutter, and machine horizontal milling machine. And it is a multi-point cutting tool. And this is the air rubber. Plane mill, this is the cutter, this is the workpiece. Both are same direction. So it is a down milling cutter, and this is the workpiece. Face milling, operation carried out for producing a flat surface which is perpendicular to the axis of rotating cutter. Face milling cutter which is used, and the machine is vertical. In face milling, the cutting edge are vertically placed and the workpiece direction is opposite to the cutting edge, and this face milling generally used for to make a depth. Here is the cutting edge which is vertically placed, and this is the workpiece which is moving opposite of the cutting edge, and this is the depth which is required. Next, in end milling, operation performed for producing flat surface, key slot, groove, or finishing the edge of the workpiece. So it is generally used for make the finishing, and the end milling cutter generally used, and this is a vertical milling machine. In here generally Remer's tool is used, and this is the workpiece. In side milling, operation performed for producing flat surface, slot, grooves, or finishing the edge of the workpiece. So here the machine tools is placed horizontally, and the workpiece and here generally it is used for make a slots or grooves, and the cutter is end milling cutter which is used, and horizontal milling machine, it is placed horizontally, so it is called horizontal milling machine. Next, slot making. Operation of producing slot like T slot and plain slot. So here it is generally making a T slot, and cutter, end milling cutter, T slot cutter and side milling cutter used, and machine is vertically placed. So the cutter tool is vertically placed, and the direction of workpiece opposite of the working tool, and it is a T slot. These are the various types of operations. This is the tool which is rotating clockwise direction, and this is the T slot, and this is the working job. Next is angular milling. In angular milling, operations of producing all types of angular cuts like V-notch and grooves and serration and angular surface. Here it is the workpiece, it is the arbor, and cutter is attached with the arbor, and here it's making a V-notch, and here machine is horizontally placed, so it is a horizontal milling machine. Next is form milling operation. Operation of producing all types of angular cuts like V-notch and grooves, serines and angular surface, and cutter. Here double angle cutter is used, and it is an horizontal milling machine. So this is the arbor, and this is the cutting tool, and it is a round corner shape cutting tool, and which is mounted on the arbor, and this is the working job. And form milling generally used to perform irregular shapes like V-notch and grooves. So here also we used various types of cutting tool like convex and concave. So this is the concave type cutting tool which is performed to make a convex type job. So this is the job. And next is straddle milling. Straddle milling operations two parallel surfaces simultaneously on a workpiece, and cutter mainly here used more than one cutter, and this is an horizontal milling machine because this is the shaft and cutting tool is mounted on it, and it is the horizontal direction. This is the workpiece, and this straddle milling machine generally used to make a proper or fixed shape between the two cutting tool. And here we used generally left hand side cutting tool teeth and right hand side cutting tool teeth to perform this operation. Next is gang milling. So gang milling and straddle milling, there is the difference, only one difference, which is in straddle milling we used two cutter, and in gang milling we used more than two cutters. So this process to get different profile on the workpiece simultaneously with two or more cutters at one stretch. And cutters, different cutters are required. Here you can see between two cutters we make a proper shape, and this the between cutter is used generally performed to finishing the surface. So here total three cutters is used, and it is a horizontal milling machine because the shaft or arbor is in horizontal direction, and these cutting tools are mounted on it, and this is the workpiece. Next is profile milling. Profile milling generally used in CNC machine or computer program control machines, and this is the outside periphery or flat part is cut, and conventional and milling is used to cut the outside or inside periphery of the flat part. So profile milling machine generally used, and it is in repeated process. This performed repeatedly. And next is pocket milling. Same, this pocket milling also performed by CNC machine, and these tools are generally used to perform automated work, and the tool direction is vertical. So another form of end milling used to mill shallow pocket into the flat parts. Generally, they use the flat surface to perform this operation. Next, surface contouring. The ball notch cutter feedback and forth across the work angle or conveyor path at close interval to create a three-dimensional surface. So here we can perform three-dimensional work, like in pocket milling. There we can perform only two-dimensional work. In surface contouring, we can use three-dimensional work, like here is the feed process, and the direction of the tool rotation is clockwise, and it is a vertical type milling. So these are the topic that we have discussed. Thank you.